Hi, my name is Oriel Marshall, and I'm a PhD student at the universities of Copenhagen and Antwerp. And today I'll be talking about the insights into science teacher partnerships during the creation of Exoplanet science lessons. To give you some context, I'm part of a research network which looks into modeling protoplanetary disk and exoplanet climates and atmospheres. And what I'm doing as my project is translating those into educational materials. And so I wanted to focus today on the specifics of this initial development stage. The method that I used for creating these was using scientist-teacher partnerships. This is the idea of collaborating with scientists and teachers. So the scientists that we're working with are the 13 PhD students who are doing a straight astrophysics PhD as part of my network. And then the teachers we're working with were 5 geography and physics teachers from Flanders who were volunteers. And so through this collaboration, we created a set of inquiry-based lesson materials. And the reason that we chose inquiry-based science education is because it's student-led, mimics scientists' actions, and it's very hands-on learning. And because one of the purposes of this project is that we're integrating contemporary research into the classroom, that we felt that having the students mimic scientists' actions was an appropriate parallel for the research going on within the scientists' work that we're bringing in to these materials. So the theory that I'm using for this project that I'll be mapping the scientist-teacher partnerships idea onto is the model of educational reconstruction. This is a model which is often used for creating educational materials based on contemporary research, so modern topics that aren't yet in the curriculum. And this is built upon 3 pillars. So there's the bottom left here looking at the analysis of science content and structure. And then on the right here is looking at analysis of science, student perspectives and learning processes. And then at the top, there is design and evaluation of learning environments. For this talk, I've summarized these into scientific input, pedagogical input, and lesson design. And these are going to be covered by the scientists, the teachers, and myself, the educational researcher, in this sort of diagram where they're all interplay with each other. And I've broken down the sort of activities, the steps within this partnership into a few key elements. So we have interviews with the scientists, familiarization with research topics, and individual feedback from the scientists. And then mirroring this is interviews with the teachers, reviewing existing educational materials, and individual feedback from the teachers. And then in the lesson design, we have some independent theory-driven development, and then some co-development with the teachers and scientists, which is where this scientist-teacher partnership really comes into play. The timeline here, this shows the different activities and how they're broken down. It's shown very linear here, but this was a design-based research project, and so the last few steps, particularly the development and feedback, was much more iterative. There were many cycles of it, but it's shown linear here just for ease of viewing. First, we'll look at the initial interviews and familiarization with research, where this is the initial collaboration between the scientist and myself. We had interviews with each of the 13 scientists, and I haven't done the full analysis that I'm going to show here. I'm just going to show you a very broad overview. So we coded all of the notes from these meetings, and the topics that came up the most often with the scientists were models and simulations, atmosphere, clouds, and planets, which makes sense given the topics of this network. So I then went on to familiarize myself with the sort of content of this lesson being clouds and lightning in an exoplanet setting, as you can see from some of these images that are output from the network on the right. So this is clouds and lightning, respectively. And then we used this initial sort of topic selection and went on to look at some interviews with teachers. So we asked them about these topics and sort of what their thoughts were about bringing these into the classroom. The top 5 topics that were discussed by the teachers during this was the scheduling and the level. So scheduling being sort of practical matters about the timing in the lesson and their timing within the school structure. And then the level here is referring to presenting the materials at an appropriate level for the audience with which they're going to be taught to. And then some more broader topics such as astronomy, physics, and geography. I then also went on to have a look at AZERO, ASTRO-IAU, and ESA Teach with Space to look if there are any existing resources in this field. Based on these first two sort of interventions, we then went on to do some independent theory-driven development, where we looked at the overlap between the two, looking at sort of triboelectric charging and electricity and static electricity for the lightning, and then looking at cloud formation, condensation, nuclearization, and saturation, humidity. And so I started creating some ideas for activities that could be done in the lesson. And then we went into the co-development, and I showed these prototypes to the teachers and scientists in order to get feedback on the prototypes and the lesson structure and the scientific validity of it, so that we could improve and develop this lesson together. We created two different scientist-teacher partnership groups. One was focused on the clouds, which had a geography teacher and 3 cloud scientists, and then one that was focused on lightning that had a physics teacher and 2 lightning scientists, both looking at exoplanets, naturally. And so in the previous section, I was trying to focus on the sort of overlap of the two, so where they both joined together, so we could choose an appropriate topic that would suit them both. Whereas now in this co-development, it wasn't just about where we overlapped, and also not just about the scientists and the teachers, but also as my own input as an educational researcher. But we were also looking at the individual strengths that both bring. So if you remember, the scientists talking more about specifics and atmosphere and modeling, and then the teachers looking more at logistics and the level and sort of practicalities within the lesson, and then myself looking at a sort of more broader holistic view and acting as mediator between the two. So through these, we created these sort of physical models that could be used in the classroom that fit both practical, pedagogical, and scientific criteria presented by all the participants. And then we went in to test these out and get feedback from the participants. So we had on the left here, you can see the scientists trying out the models and giving written feedback on the materials, and then the teachers trying them in their lesson and having interviews with myself afterwards. And so through this process, we resulted in this set of lessons, which you can find online if you're interested. But overall, what I wanted to sort of take away from this is this idea that you can really look into getting not only the best of the overlap between them, but really benefiting from all of the qualities and skills that each people present in this group setting. And I think that scientist-teacher partnerships can be a really beneficial way of integrating topics such as astronomy topics like exoplanets into the classroom in a way that is valuing all of the different voices within this. Thank you very much for your attention.